Hey guys, so we are in day 7 of quarantine and social distancing. Today we're going to talk about 4-2, solving systems of equations by substitution. So I want you guys to think about how we're solving these. We're solving it by substitution, so think about what the word substitution means. So for instance, like when I'm absent and you guys have a substitute teacher, well, that teacher is there replacing me for the time being. All right, so when we're solving a system of equation by substitution, our first step that we want to do is we want to isolate a variable. Now I say isolate a variable because we can either isolate x or y. Now it doesn't matter which one we're isolating, we have to look at the problem to determine whichever is easier. Right after we've isolated one of our variables, then step 2, we want to substitute into our other equation. Now, we're going to get what one of our variables is equal to. We're going to take that solution and put it into our other equation. So it'll make sense once we go through the example. All right, step 3, we're going to solve for the remaining variable. Now I say remaining because when we get to step 3, we're getting rid of either our x or our y. We'll only have one variable to solve for. So we're going to solve for the remaining variable. And step 4, we're going to plug in what that variable was equal to into our equation to solve for the other variable. So our solution will still be an ordered pair of x, comma, y. Alright, so let's take a look at our example 1. We have x minus y equals 11 and negative 6x minus 3y equals 6. Alright, so we're going to look at each of these two equations and we're going to select whichever equation is easier to get a variable by itself. Now, the second equation, each variable has coefficients in front of it, so that one's going to be a little more difficult. So I'm going to choose the first equation. So I'm going to take x minus y equals 11, and I'm going to either solve for x or solve for y. Now, you want to use whichever is easier. I'm going to say the x is easier because if I solve for y, I get a negative y, and I want to keep my variable positive. So I'm going to add y to both sides, so we get x equals y plus 11. Alright, so now that we've isolated a variable, we got x by itself, we solve for x. I'm going to take what x is equal to, which is the y plus 11, and I'm going to substitute it in for my x in my other equation. So now I'm just going to rewrite negative 6, but instead of x, I'm going to replace x with y plus 11 minus 3y equals 6. Alright, so now when we look, I don't have an x in this equation anymore, I just have a y. So now we're going to solve for y. So first I have to distribute my negative 6, so we get negative 6y minus 66 minus 3y equals 6. Right, then we have to continue solving for y, so I'm going to combine my like terms, which are my negative 6y and negative 3y, so we get negative 9y minus 66 equals 6. I'm going to add 66 to both sides, so we have negative 9y equals 72. And then lastly, divide both sides by negative 9, so y equals negative 8. Alright, in our last step, we're going to take what y is equal to, so we have one solution for y, I have negative 8, And I'm going to take that and I'm going to plug it back into y. So when I plug it back into that equation for y, I'm going to solve for x. So x is equal to 3. So our final answer is the coordinate 3, negative 8. Alright, so let's look at example 2. We have x minus 4y equals negative 12 and negative 2x plus 8y equals 24. Alright, so we're going to look at each of these two equations and determine which of the two equations is easier to get a variable by itself. So again, I'm going to use my top equation because one of my variables, the x, doesn't have a coefficient in front of it. So I have x minus 4y equals negative 12. And then I'm just going to add 4y to both sides to get the x by itself. X equals 4y minus 12. Alright, so now I'm going to take what x is equal to, and I'm going to plug it into my other equation. So we get negative 2, but instead of x, I'm replacing the x with 4y minus 12. And then we finish our equation, plus 8y equals 24. Alright, so now we just have to solve for y. We have to distribute first, so negative 8y plus 24 plus 8y equals 24. Alright, so now we have to keep solving for y. So when I combine my like terms, I have negative 8y and positive 8y. One negative and a positive, they make 0, so I'm just left with 24 equals 24. Now, this is one of the special cases with systems. So we completely eliminated our variables. I don't have any more variables. We have to think about if what we're left with makes sense. Does 24 equal 24? Yeah, it does. So if you completely eliminate your variable and you get an answer that equals itself, well then we have infinitely many solutions. Alright, example 3. So we have negative x plus y equals 1, x minus y equals negative 3. Alright, so it doesn't matter which equation you use and which variable you choose to solve for. You can either use the top equation and solve for y or x, or you can use the bottom equation and solve for x or y. It doesn't matter. I'm going to use the top one and solve for y just because we've been solving for x, and I want you guys to see it doesn't matter which variable you use to solve for. So I have negative x plus y equals 1. I'm going to add x to both sides to get y by itself. Y equals x plus 1. So now we're going to take what y is equal to, which is x plus 1, and substitute it into y for our other equation. So we have x minus, parentheses, what y is equal to, which is x plus 1, equals negative 3. Alright, so now I want to solve for x. But before I can get rid of the parentheses, I have to distribute this negative. Now remember, there's a negative 1 in front of that parentheses that we need to distribute. So I really have x minus 1 equals negative 3. Alright, so now when we solve for x, we're going to combine our like terms. So I have x and I have a negative x. Well, x minus x makes 0. So I'm just left with negative 1 equals negative 3. Well, here we're also left with another special case. I eliminated my variables. I don't have any variables left to solve for. And I have negative 1 equals negative 3. Now, you have to think again, does that make sense? Does negative 1 equal negative 3? Obviously no. So our answer is no solution.